All right, so your second factoring method, so you did factoring with the GCF and taking out the greatest common factor. Your second factoring method is called factoring using dots. Now that obviously stands for something. So what DOT stands for is the difference of two squares. Now, squares means something in math. It means when you actually square something. Difference is right when you see subtraction. So this means that there's going to be some sort of subtraction with some sort of squaring. And we're going to get more into that in a second. Now, all this is, the reason why I'm doing it second is because it's a shortcut that's used to factor. So you could use kind of a later method we're going to use to factor things that look like this. But if you can recognize that you have a difference, so that you see a subtraction in the problem, and that you have two squares, you can kind of shortcut and get the answer right away. So it's a shortcut used to factor an expression that looks like x squared minus y squared. Now you're going to have numbers here and here, but the important thing is, again, subtraction and stuff being squared or to the fourth or to the sixth. So basically kind of like even powers and subtraction, as long as it works out. Now, in general, this is what the factored expression looks like. If I'm factoring x squared minus y squared, it looks like two sets of parentheses. Remember, we call these binomials. So two binomials. So it looks like x and x in the front, y and y in the back, and one's positive, one's negative. It doesn't matter if this one's positive and this one's negative or not. But you do need to know perfect squares to do this. So what we're going to do next is we're going to make a perfect square chart in our notebook. Now, I only did a perfect square chart up to 20 because realistically, I don't think that any problem is going to make you go higher than that. If they do, you will use your calculator. So squaring something, right, means to have that number to the second power. It means that number times itself. The perfect squares are going to be what we fill in. So I would pause the video and I would get the chart set up first before you listen to the next part. So 1 squared is 1. That means 1's a perfect square. 2 squared is 4. 3 squared, 9. Let me move this mouse out of your way. 4 squared, 16. 5 squared, 25. 6 times 6 is 36. 7 times 7, 49. 8 times 8, 80. Just kidding. 64. I said 8. I wrote 8. 9 times 9, 81. 10 times 10, 100. Those you really should get to know off the top of your head. So if I say, is 10 a perfect square? No, 10's not on here. Yes, 10 squared is 100, but the perfect squares are what I wrote in purple. If I say, is 36 a perfect square? Yes, 36 is a perfect square. To be a perfect square, it means that there is a number that you can multiply by itself to get you that number. So 36 is a perfect square because 6 times 6 gives me 36. Okay, these ones, if you need a calculator, feel free to use it. Okay, so you can type in 11 squared, you get 121. You could type in 12 squared, 144. 13 squared, 169. 14 squared, what's kind of nice is that these just switch, 196. 15 squared, this one is a popular one that you will see, 225. 16 squared, 256. 17 squared, 289. 18 squared, 324. 19 times 19, 361. And 20 times 20 is 400. Now, realistically, to have a square that's higher than 400 is going to be very obscure in your problems that you guys will be doing. All right, so this is going from squares and actually getting the perfect squares. The reverse of squaring something is taking the square root or using your radical sign. So if I ask you, okay, so what's the square root of 100? Well, if you use your calculator, whichever one you have, and you type in the square root of 100, it's going to say 10, because if I look at my table, 10 squared is 100, okay? So the square root of 10 is 100. Or sorry, 100 is 10. The square root of 144 is 12. So if I ask you, okay, use the difference of two squares. Here's a difference. 100 is a perfect square. This is an even power. 144 was a perfect square. This is an even power. I'm asking you to set up your parentheses. Well, what gives me 100? 10. So a 10 and a 10. X squared. So each one gets an x. Okay, because 10x times 10x gives me 100x squared. 144, what we said was 12. So they both get a 12. Y times y, so 1 and 1. And then, like we said before, 1 is positive, 1 is negative. So you could write it like that, or you could write it like this. It doesn't matter which parentheses you make positive and which is negative, as long as one's positive and one's negative. So this would be the factored form of that expression. All right, we're going to go on to some practice, and I do assume that you guys are probably going to pick this up pretty fast. So if I'm looking at a problem, I notice that this has an even exponent, and this 64 is a perfect square. I can test it in my calculator by checking to make sure that if I have a square, if I take the square root of it, I get 8. That means I can just set up my two parentheses. If I have x squared, that gives me an x and an x. We just found out that it's 8, or we looked at our list, and one has to be positive and one has to be negative. That's it. Example 2 is, it looks a little different. I'm not even going to move it because now there's numbers in both. Here, technically there was a number. It was a 1, and you could put a 1 and a 1 if you wanted to, but you don't need to. So if I look at this one, 16, so if I check it, it's a difference. All right, now I want to check an even power. So I say, okay, 16, the square root of 16 is 4. So that one works, but does 9 work? Yep, I get 3. So that means this is a 4 and a 4. This is a 3 and a 3 for numbers. The 16 has an x squared, so I need an x and an x. One positive, one negative. Okay, example 3. So I see subtraction, good. I see an even exponent, good. Now I check. Is 121 a perfect square? Yep. Is 4 a perfect square? Oops. There we go. Sorry, guys. Yep, it's 2. So I get 11 in the front because that's where the 121 was. 2. Now 11 didn't have any variables. 4 did. B squared, so I have a B and a B with the 2 because that's where the 4 came from. 1 positive, 1 negative. 1 negative, 1 positive. Doesn't matter. All right, and now 4. Let's do the same thing. So we check 9 and 25. 9 works. 25 works. Now I have two variables, but this is an even power, and this is an even power, and I have subtraction, so I'm good. I check the numbers, check the powers, and that it's the difference. So we found out this was 3 and 3. This was 5 and 5. Now G, 2, so I need a G and a G with the 3. And H2, so I need an H and an H with the 5. 1 positive, 1 negative. And on your edge elastic, I'm going to put in both ways. So I'll also put this as an answer. And if for some reason something's typed in wrong, you know I check it and go back. So don't panic. All right. We're going to do actually only 2 more. We're going to do example 5 and 7. So here's subtraction. Great. 4 is even, so I'm good there. But now I have 625, and that is not on my list, so I have to check it, and I get, 25. So sometimes you're going to see a big number, and that's okay. So a 25 and a 25. Now, if I have x4, if I just put x here, that would be x1 and x1, which would give me x2. So I need x4. That means I need to put 2 here and 2 here to get me 4. So again, I put 2 here and 2 here because I have 4. In the past, right, this was just 2, so I had 1 and 1. Again, 1 positive, 1 negative. This might be the shortest video that you guys had to watch because it's a shortcut. All right, 7. I see a difference, but this is not a even number. So now sometimes it's going to be a combination of what you did with GCF and this. Well, if I think about what these have in common, and I factor out my GCF, 1 and 5 and 5 x's. This has 1 and 45 and 5 and 9 and 1x. Well, 5 is in common. That's the smallest or the biggest number. And then this smallest x is 1. So if I take out 5x, I'm left with 1, x4, minus 9, and no x's because I took it out. Oh, now I have a subtraction. Now I have an even exponent. And 9, if I check it, and we did this one before, is a perfect square. So what kind of happens here is I kind of have to use 2 strategies in one. So 9, we got 3. Just like before, if this is x4, that means I need x2, x2. 1 positive, 1 negative. But now what do I do with that 5x? I just copy it down and leave it out there. So it's kind of a 2 for 1. I used the old way, so I could use the new way. And that would be my final answer. Again, reach out if you have any questions. Hopefully, all of these notes, I believe every single one looks like one of your examples that you have to do. So you should be good to go. Nice job again. Thanks for watching.